For a decade, the electric vehicle revolution was a simple story: build a bigger battery. But we have reached the limit of that story. The next chapter, the one that will define the future of the automobile, is far more complex, more ambitious, and infinitely more exciting. It's about making the battery disappear, not literally, but by integrating it so deeply into the very structure of the car that the line between battery and body blurs into nothing. This is the era of cell-to-body and cell-to-chassis. Today, we are staging the ultimate engineering showdown: BYD's CTB2, Tesla's radical CTC, and CATL's elegant Qilin. The battle is no longer about the battery, it's about the car itself. To understand the significance of what's happening, we need to go back in time. The first generation of electric cars treated their batteries like a piece of luggage, a heavy backpack. This was the module era. Individual cells were bundled into modules, modules were assembled into a pack, and the pack was bolted onto the car. It was safe, but incredibly inefficient. Less than 40% of the pack's volume was actual battery. Then came the first revolution: cell-to-pack, CTP. This eliminated the modules, boosting space utilization to 50–60%. But the battery was still a separate passive component, a backpack. Now, we are in the middle of the second and far more profound revolution: cell-to-body, CTB, and cell-to-chassis, CTC. The battery is no longer a backpack. It is the backbone. The cells and the pack structure are now integral parts of the car's skeleton. This shift is creating a technological divergence, a fork in the road. BYD's approach is a direct extension of their fortress-like vertical integration strategy. They call it CTB2, and its core philosophy is to turn the battery pack into the car's floor. They use their unique blade battery, long thin cells arranged like structural beams. In the CTB2 design, the car's own floor panel serves as the top of the battery enclosure. The result is a vehicle sandwich. The battery is an active structural component, contributing immense rigidity. This is why a BYD seal with CTB can achieve a torsional rigidity of over 40,000 newtons-meters divided by degree, a number worthy of a high-performance sports car, and why it can withstand the crushing force of a 50-ton truck. If BYD's approach is to make the battery the floor, Tesla's is even more radical. With CTC, they aim to make the battery and the floor disappear into one single entity. Tesla completely eliminate the concept of a battery pack as a separate box and the traditional floor panel. They take their 4,680 cylindrical cells and arrange them directly into the car's chassis structure, then bond them with a special structural adhesive. The seats are then mounted directly onto this integrated cell chassis structure. This approach is an obsession with manufacturing efficiency. By integrating everything, Tesla was able to eliminate 370 individual parts, reduce the vehicle's weight by 10%, and cut the cost of that part of the car by 7%. It is a manufacturing revolution. CATL, as the world's leading battery supplier, plays a different game. Their innovation, the Qilin, or Kirin, battery, focuses on perfecting the battery pack itself. The genius of the Qilin battery lies in its internal architecture. The breakthrough is what they call the multifunctional elastic interlayer. This is an ingenious component that acts as a structural support, a cushion, and it integrates the liquid cooling plate directly against the largest surface of the cells. Inside this inner layer, a micrometer bridge connection device allows the structure to flexibly accommodate the cell's breathing during its life, enhancing reliability. This large surface cooling is a masterstroke. It increases the heat transfer area by a factor of 4, enabling insane charging speeds. With a volume utilization of 72%, it is the most space-efficient battery pack ever mass-produced. But these designs don't exist in a vacuum. They are a direct reflection of each company's manufacturing DNA. BYD's philosophy is the fortress. They are a vertically integrated empire. They control everything, from the battery materials to the final assembly. This gives them unparalleled control over cost and supply chain. CTB is the ultimate expression of this, a closed-loop system where every component is designed to work perfectly with the next because they make all of them. This allows them to achieve incredible cost-effectiveness and reliability. with a final production yield rate of 99.5%. Tesla's philosophy is the revolution. They are obsessed with first principles thinking, not just about the car, but about the factory itself. The gigapress is the key. CTC is not just a battery technology, it's a manufacturing process designed to eliminate steps, eliminate parts, and simplify assembly to an extreme degree. Their goal isn't just to build a car, it's to build the machine that builds the machine. This explains their high-risk, high-reward approach. CATL's philosophy is the empire. They are the ultimate arms dealer of the EV revolution. Their goal is not to build one perfect car, but to build the most powerful, flexible battery platform that can be adapted by dozens of automakers, from Zeekr to Xiaomi. Their manufacturing genius lies in scale and quality. Their lighthouse factories operate at a semiconductor-grade standard, with a single-cell defect rate at the parts per billion (ppb) level, while the industry norm is parts per million. These manufacturing philosophies explain why they chose their paths, but this genius means nothing if the car isn't safe. Integration is great, but what happens when something goes wrong? BYD's defense is chemistry and structure. The Blade battery's LFP chemistry's thermal runaway temperature is over 500 degrees Celsius. In a crash, the sandwich structure and the internal beam-like blades distribute impact forces. Tesla's defense is management and engineering. They use a more volatile NMC chemistry, so their defense relies on their world-class battery management system, BMS, which monitors every single cell in real time. The CTC pack is designed to vent the hot gas away from the passenger cabin through pressure relief valves. CATL's defense is isolation and intelligence. Their goal is zero thermal propagation. The multifunctional interlayer acts as a firebreak, using advanced insulation materials like aerogels. Their system can detect an impending failure and trigger a thermal electric separation, physically isolating the faulty cell. Ultimately, it all comes down to performance. In energy density, CATL is the king. The Qilin battery achieves a system energy density of 255 watt-hours per kilogram. This is what enables cars like the Zeekr 001 to break the mythical 1,000-kilometer range barrier. In structural efficiency, BYD and Tesla hover around 210 watt-hours per kilogram. BYD achieves this with cheaper LFP, highlighting their superior packaging efficiency. In charging speed, CATL again takes the crown. The Qilin's large surface cooling supports a true 10-minute fast charge, from 10% to 80%. But here is the final crucial trade-off: repairability. This is the greatest challenge for Tesla's CTC. When the cells are a structural part of the car, the answer to chassis damage is often a full pack replacement. A repair that can cost upwards of $15,000 to $20,000. BYD's CTB offers a better compromise. The Blade battery's design allows for the replacement of individual blades, with the report showing a 60% reduction in repair costs compared to traditional packs. CATL's Qilin retains the traditional model of serviceability, as it can be dropped from the car and repaired as a single unit. This is the fundamental trade-off: radical integration for manufacturing efficiency versus serviceability for long-term ownership. So, who is winning the battery war? The answer is, they all are. This is not a zero-sum game. It's a powerful demonstration of three different, brilliant solutions to the same, complex problem. BYD's CTB2 is the ultimate expression of pragmatic, cost-effective engineering. Tesla's CTC is a testament to radical, manufacturing-first innovation. CATL's Qilin is a showcase of pure, unadulterated battery science. They are pushing, pulling, and inspiring each other. The battle for the heart of the electric car has evolved into a battle for its very soul and skeleton. So, the ultimate question is, are you willing to risk Tesla's $20,000 repair bill for the sake of manufacturing elegance? Or do you prefer the serviceability and safety of BYD divided by CATL? Which philosophy wins your wallet? Integration at all costs, or modular design for the consumer? Let me know your thoughts in the comments below. If this deep dive into the engineering battles of our time gave you a new level of appreciation for these incredible machines, Please give this video a thumbs up, subscribe to Volt China, and hit that notification bell. The future of the car is being forged in these factories, right now. Thanks for watching, and I'll see you in the next one.